Hello, and welcome to this lesson on mass number. In today's lesson, we will dive into the concept of the mass number of an atom and understand its significance in determining the total number of nucleons, which includes both protons and neutrons within the nucleus. The mass number of an atom, also known as atomic mass number, is defined as the sum of the number of protons and neutrons present in its nucleus. Protons and neutrons are collectively referred to as nucleons because they reside within the nucleus of the atom. So, the mass number tells us the number of nucleons in an atom. This value is always a whole number. Whilst they sound similar, it is important to note that the mass number is not the same as the atomic number, which only counts the protons and determines the element's identity. Imagine we want to draw an atom of carbon. Since we know the atomic number of carbon is 6, then it must have 6 protons. In a neutral atom, we have an equal number of protons and electrons, so we can also draw 6 electrons in the correct configuration on the electron shells. If you're unsure of this step, then revisit our earlier lesson on electron configuration. Now for the neutrons. This atom could have a varying number of neutrons, and we therefore do not know straight away how many to draw. To know how many neutrons we need to know the mass number of the atom. A common form of carbon atom is carbon-12. The 12 here refers to the mass number. This means that within the nucleus of this carbon atom, there are a total of 12 nucleons. We can therefore determine the number of neutrons by subtracting the number of protons from the mass number. So, for carbon-12, the mass number is 12, and the number of protons is 6, so the number of neutrons must be 6. Therefore, a carbon-12 atom has 6 protons and 6 neutrons in its nucleus. The mass number gives us essential information about the composition of the atom's nucleus. Understanding the mass number helps us not only determine the basic structure of the atom, but also allows us to differentiate between isotopes. Isotopes are atoms of the same element that have the same number of protons, but different numbers of neutrons, hence different mass numbers. For example, we just looked at carbon-12, which had a mass number of 12 and therefore 6 protons and 6 neutrons in its nucleus. But it is also possible to have carbon-13, which has a mass number of 13. This has 6 protons and 7 neutrons in its nucleus. We will look at isotopes in more detail in the next couple of lessons. Let's dive into some GCSE level questions to apply our understanding of the mass number and how it determines the total number of nucleons within the nucleus. Question 1. An atom of magnesium has a mass number of 24 and contains 12 protons. How many neutrons are in the nucleus of this magnesium atom? Pause the video here to have a go at answering the question. Now, here's the answer. Firstly, we need to identify the mass number. This is 24. Then we identify the number of protons. This is 12. Now we can use the formula. Number of neutrons equals mass number minus the number of protons. Finally, we calculate the number of neutrons. 24 minus 12 equals 12. Therefore, the nucleus of this magnesium atom contains 12 neutrons. You can visualize this by referring to the diagram, where you would see 12 red spheres, protons, and 12 blue spheres, neutrons, within the nucleus. Now let's try question 2. A certain atom of chlorine has 17 protons and 20 neutrons. What is the mass number of this chlorine atom? Again, pause the video here to have a go answering this. Here's the solution. Firstly, we identify the number of protons, which is 17. Then we identify the number of neutrons, which is 20. Finally, we use the formula. Mass number equals number of protons plus number of neutrons. To calculate the mass number, 17 plus 20 equals 37. Thus, the mass number of this chlorine atom is 37. These examples illustrate how to determine the number of nucleons in an atom's nucleus using the mass number and the number of protons. This skill is fundamental for understanding atomic structure and the differences between isotopes. In today's lesson, we learned that the mass number, also called the atomic mass number, is the sum of the protons and neutrons present in an atom's nucleus. This number is essential as it helps us understand the overall mass of the atom and distinguishes different isotopes of an element, which have the same number of protons but different numbers of neutrons. We will cover this material in more detail in the upcoming lessons. We also discussed how to calculate the mass number by simply adding the number of protons and neutrons together, also known as the nucleons. We recognize that the mass number is not the same as the atomic number, which only counts the protons and determines the element's identity. By understanding the concept of the mass number, we can better comprehend atomic structure and the composition of different elements. This knowledge lays the groundwork for more advanced topics in chemistry, such as isotopic notation, atomic mass calculations, and nuclear reactions.